can interact with a contract. But let's just go ahead and add everything so that if we want to interact with more things, we can. So now we have the ABI. We also now need an address, which we can definitely find from the Aave documentation. We can go to their deployed contracts section. We can find lending pool addresses provider, which is going to be right here. We're going to copy that. And where are we going to put this? Well, as you know, we're going to put this in our Brownie config. We're going to do lending pool addresses provider. We're going to paste that right there. And since we know we're also going to do Coven, we can also grab from Coven here. So lending pool addresses provider. We're going to copy this here and we're going to add this addresses provider for Coven as well. Boom. And now we have it for both Coven and for mainnet fork. Awesome. So we can keep going now. Now that we have an ABI and we have an address for both Coven and for our mainnet/mainnet fork, what we can do now is we first get the lending pool addresses provider. It's going to be from our interface, which again, we're going to grab from Brownie. Interface.i lending pool addresses provider, which the address of that is going to be config network.showActive lending pool addresses provider. And then we're just going to say lending pool address is going to be equal to lending pool. I'm just going to copy and paste it instead of typing the whole thing. Address divider provider dot get lending pool. Right? Because again, this address provider has this get lending pool, which returns this address, which is the address of the lending pool. Then, now that we have this address, we can actually return the lending pool contract by once again getting the ABI and the address of the actual lending pool. So we have the address, check. We just now need the ABI, which once again, we can work with our wonderful interfaces here. Do new file, I, lending pool, sol. And there's only going to be a couple of functions we're going to work with here, but Aave actually gives us the interface right here. And Aave actually even gives us the interface of the lending pool address provider for us. So we can go ahead and copy this, pop it over into here. Now we do need to actually change one thing in here as well. This interface imports locally with this /. So we actually just need to change these imports to actually import directly from GitHub instead of importing locally. Luckily, this is something we already know how to do. So let's go to our Brownie config. And up at the top, we're going to add this dependencies bit in. Dependencies. So we're just going to work with Aave's protocol right from GitHub. So we're going to work with Aave/protocol v2. And let's see what their latest version is. Ooh, looks like they got a couple different versions here. 1.0.1. So let's go ahead and work with this one. At 1.0.1. And then with compiler, sulk, remappings, per usual, we're going to say at Aave is going to be equal to this dependency. This way, Brownie will download this right from GitHub, and now we can just use this at Aave instead. So back in our ilendingpool.sol, we can just change this to pull right from GitHub. And if we look in GitHub, we go to their contracts section, we go to their interfaces section, ilendingpool. We know that we can pull this from at Aave/contracts/interfaces, because we see this ilendingpool addresses provider right in here. And then this data types bit, you can actually look in contracts. And this I know because I've been through already. It's in protocol, libraries, types, And here it is, data type.sol. So we can just take this exact path again and do @ave/contracts /protocol/libraries/types data type.sol. Okay, great. So now that we've actually imported this interface for us to use, we can go ahead and compile just to make sure that everything is working correctly. Brownie compile. And perfect. If these interfaces had an issue, they actually wouldn't compile through Brownie here. So we know that they're compiling correctly. But great. So now that we have an interface, we know that these interfaces compile down to the ABI, and we already have the address here. So to actually interact with the lending pool now, we can just do lending pool equals interface dot I lending pool, and we'll add this lending pool address, lending pool. And then we can return lending pool. So now we have a function that goes through the lending pool addresses provider from the Aave documentation and returns this lending pool contract that we can now interact with. And we can even test this out by just printing this lending pool address in our script. So we'll do Brownie, run, scripts, Aave borrow, network, mainnet fork. And perfect. We can see the address here is printed out and there are no errors. So we know we're doing it right. So now that we have the actual address, what we're going to do now is we're going to take this wrapped Ethereum that we've got, this ERC20 version of Ethereum, and we're going to deposit it into this contract, just like what we did in the user interface. In order to actually first deposit it, we need to approve this ERC20 token. ERC20 tokens have an approve function that makes sure that whenever we send a token to somebody or whenever a token calls a function that uses our tokens, we actually have given them permission to do so. So that's the first thing that we're going to actually have to do is we're going to have to approve sending our ERC20 tokens. And this resembles, so since I know that we're going to have to approve a lot, I'm actually just going to go ahead and make an approve ERC20 token function, similar as to what we did with the get lending pool. So we're going to need to approve this ERC20. So we're going to need to approve this ERC20. So let's go ahead and make a function. We'll call it def approve ERC20. So how do we actually call this approve function on a token contract? Well, as always, we're going to need the ABI and the address of the token contract. Same as always. I told you I was going to be saying this a lot. Now we could create our interface ourselves, looking at all the functionalities of the ERC20 tokens. So we could go to EIP20, look at the token standard, find all the different functions and put them into our interface. Or we can go ahead and just cheat and just grab it from my GitHub repository here. So I already have an IERC20.sol right here. And we're just going to copy everything in here and add it in a new file called IERC20.sol and paste it in here. So you can see there are a number of different functions in here. We can check the allowance. We can check the balance of different addresses, how many decimals a token has, the name, the symbol. We can do some transfers and transfer from. And then the function that we're going to be using is this approve function. So right here, we can already see the parameters this approve function takes. We're going to need to have a spender of who to approve can spend our tokens, and then how much they can actually spend. So if we come back over to approve ERC20, we know that for input parameters, we're probably going to need an amount, a spender address, the ERC20 token address, so which token we're actually allowing to spend, and then an account, right? Or this is going to be that from account bit. So we'll just have this be passed as part of the function parameters. So let's go ahead and code this. Let's first just do a quick print line so that people know what this transaction is doing. We'll say approving ERC20 token. And then we'll get the ERC20 token by saying ERC equals interface, same as always, .IERC20. And then we'll give it whatever ERC20 address that we pass to this function. And now we can actually interact with this contract and we can call that approve function. So we'll say transaction TX, or again, TX usually stands for transaction, equals ERC20. approve, and we're going to approve this spender for an amount. And then we'll say from account. We'll do a tx.wait. We'll wait one block confirmation for it to finish. And then once it's done, we'll do print approved, and we'll return the transaction. Awesome. So now we have an approve ERC20 function that we can use to approve any ERC20 token. So back up at our main function, we can run approve ERC20 for some amount, which right now we don't have defined. The spender is going to be this lending pool, but the address of the lending pool, because remember, lending pool is the entire contract. We just want the address. The ERC20 address, of course, is going to be the ERC20 address, and the account, of course, is going to be our account. The only thing we don't have defined right now is some amount, which we can make it really whatever we want to be. To keep things standard, let's just go ahead and do 0.1. So I'm going to make this a global variable. I'm going to say amount equals 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7. And we can go ahead and do amount. We're going to import,
now, of course,
Web3.
doing all these zeros
so
is
from
incredibly disgusting.
Web3.
So we're just going to
Import
refactor to do from Web3, import Web3.
And then instead of always,
and we'll just do
Web3, the
two-way 0.1 ether.
0.1, which is the amount that we actually want. And we'll say ether. Now we can run Brownie, run scripts, Aave borrow.py, network mainnet fork. And we can go ahead and see that our approval function is working as intended. Network that will
now,
always be
doing this
defined
dash
whenever we
network
run any type of
fork
Brownie
flag
script.
can get a little annoying.
So we can do
so
default.
let's just go ahead and change our default network to mainnet fork.
Mainnet
so we don't have
fork
to do any network
in
flag.
our Brownie. Let's go back to our Aave borrowing section now. So we have everything approved. Now we just need to go ahead and deposit it into Aave. Since we know we're probably going to use this a lot too, let's go ahead and create a deposit function. Since we have everything approved, we can now go ahead and use the lending pool deposit method. And we can check the documentation here or look on GitHub or Etherscan to see what the parameters that it takes are. So I'm even just going to go ahead and copy all this, bring it over here. So what we can do now is we can do lending pool dot deposit, and then all these parameters. Let's go ahead and walk through them one by one. So first thing is going to be the address of the asset, which we know is going to be our ERC20 address. Boom. The amount of the token, which we can go ahead with our amount variable. Address on behalf of is just going to be our account.address. We're depositing this collateral for ourselves, and then referral code. So referral code is, the referral code is actually deprecated, and referral codes don't actually work anymore, so we're just always going to pass 0 here. And just to make sure we know that this is what we're doing, we're going to go ahead and print depositing, 1, 2, 3, and then after we're done, we're going to do print deposited. And whoops, looks like we forgot to add that final dictionary here of from account. One more thing here. Let's go ahead and do tx for transaction equals lendingpool.deposit. And we're going to go ahead and once again, we're going to wait for one block confirmation. Wait 1. Transactions still being processed. So now if we run Brownie run scripts, Aave borrow.py, we can see that this actually went through fine. All right, now that we have some collateral deposited, we can go ahead and actually take out a borrow. We can go ahead and borrow some other asset. The question is going to be, how much? How much can we actually borrow? How much should we borrow? What would result in a positive health factor? Well, maybe we should actually pull off chain some of our stats. How much do we actually have deposited? How much collateral we have? How much debt we have? And so on and so forth. That way in the future, when we don't start clean, we can take some inventory of where we stand with our collateral and our debts. At the Aave documentation, we can go ahead and see this function called get user account data. This is going to return the user account data across all reserves. So it's going to get the total collateral that we've deposited in terms of Ethereum. It's going to get our total debt in terms of Ethereum, how much we can borrow, the borrowing power that we have, the liquidation threshold or how close to that liquidation threshold will be, the loan to value ratio, and again, this health factor. This health factor is obviously incredibly important because if